We're going to take a look at a few optimization problems in this section, and we're going to break those up into multiple parts and multiple steps just because these do tend to be longer problems, and I want to see if we can kind of come up with a step-by-step process that will help us solve these problems, make it a little bit more approachable and a little bit easier to get into. In this first example, we want to find two numbers whose sum is 21 and whose product is a maximum. Relatively short and to the point here. So I want to, first of all, in step one, draw a picture if it's helpful. In this case, we're just talking about two numbers. We want a sum, we've got a product. There's really nothing to visualize here. I don't think a picture would be particularly helpful here. So I would go ahead and skip that step. Step two, though, we want to identify the variables of the problem. What is it that we're looking for here? So in this case, I see we're looking for two numbers here. So I'm going to give those two numbers variable names. How about I call the first number, I'm going to call that x, and then the second number, we need a different variable for that. I'm going to call that y. So we've got our first number is x, our second number is y. These are the two variables that we're going to be using in this problem. Let's see, step three, we want to identify the objective function. This is the function that we're maximizing or minimizing. So the first thing I like to do is figure out which one of those are we doing. Are we maximizing or are we minimizing? In this case, we're looking for a maximum, so that means we want to maximize some function, and we're going to write what that function is. Well, we want to maximize the product. We want to find a product is a maximum. So product here, I'm going to come up with a function name for this. It doesn't really matter what we call it, but I'm going to call it P for product here. And my product is equal to, well, I'm finding the product of these two numbers. When I say product, that just means to multiply those two numbers. So I'm going to multiply my two variables. So I'll have P is equal to x times y, or just P equals xy. So here is my function. This is what I'm trying to optimize. This is what's called my objective function here. Now, if I can, I'd like to find the domain of this function. In this case, I would hold off on that for just a moment here because we have two variables instead of just one. In this case, and in some cases like this, we'll end up with a function that requires two variables. We don't really know how to do calculus with two variables yet. It turns out you actually can do it. But in this case, we don't really know how to deal with the two variables. So we want to try and figure out a way, what can we do with this problem so that we can eliminate one of those variables, so that makes our problem a little bit easier. So what else do we know? I'm going to go back and look at what else this problem told me. We know that these two numbers have a sum. Their sum is 21. So I know that the sum of these two numbers is equal to 21. And sum just means I'm adding those two numbers. So if I add those two numbers, if I take x plus y, I should get 21. Sometimes you'll have a secondary equation that relates your two variables. This has a fancy name. This is called a constraint. And it's something that's constraining your variables. It's some other thing that we maybe are limited by, which is good. We kind of need that here. Otherwise, the problem is so open-ended that we don't know where to go. So what I have here is I have 21 is equal to x plus y. What I'm going to do is take this constraint equation that I found, and I'm going to solve it for one of these two variables. I'm either going to solve it for x or I'm going to solve it for y. And it turns out it doesn't really matter which one of these two I solve for. We can either solve for x or we can solve for y. It doesn't matter. So I'm going to go ahead and solve for y here just because. So to do that, I'm going to subtract x from each side. So that means that I will end up with y equals 21 minus x. Here is now this new version of this equation. And what I like to do with these constraints is once we have it, once we've identified, we've solved for one of those variables, well, now I'm going to take that and I'm going to plug that back into my objective function for y. I'm going to take out that y and replace it with 21 minus x. So instead of saying x times y, I'm going to go ahead and write that as x times 21 minus x. Now I have something that is in terms of a single variable, and I'll clean this up in just a moment here, but I have something that's written in terms of one single variable. It's only in terms of x. That is something that we know how to do calculus with. We can take the derivative, we can find our maximum, we can do our first or second derivative test or whatever it is that we need to do. We know how to approach this problem here. So that is our fourth step, is actually to write it in terms of a single variable. Sometimes the problem might already be in terms of a single variable, in which case, great, that's a step you don't have to do. But in this case, we did. So we have this kind of new equation. I'm going to bring this down here. We've got p is equal to, and I'm going to distribute here as well, I'll distribute that x. We've got 21x minus x squared. This is the function that I'm trying to, again, I'm just going to make a note to myself that I want to maximize this function. Now this is something that has a single variable. It's something that we know how to deal with. Now, the other thing I want to do before I get into derivatives and calculus is I want to think about the domain of this function. Are there any sort of restrictions on my x variable? So what I would do is I would go back to the beginning of your problem. I would read it over very carefully here. So we wanted to find two numbers that have a sum of 21 and have a maximum product. The only constraint I see is the sum of 21, and we've actually already included that. We've counted for that. It doesn't say anything like maybe two positive numbers. Then I would have to worry about, well, I can't choose a negative number. It has to be positive. It just has two numbers. So what I'm going to do then is I'm going to say the domain of this function, and I can just kind of do this off to the side. The domain of this function, because there are no restrictions on x, the domain would be negative infinity to positive infinity. Now, we want to hold on to that idea for right now, because in the next video, once we start to use the calculus and we start to try to find our maximum or minimum value, how we determine if we have a maximum or a minimum is going to be dependent on our domain, whether we have an open interval or whether we have a closed interval. In this case, we've got an open interval, which means we're kind of hoping that we have just the one single critical point, and we'll have to verify that that is in fact a maximum here. So at this point, we've got just about everything that we need to set this problem up, which means in the next video, we should be ready to go ahead and find our derivative, find our maximum, and finish this problem up.